Lesson 3.1, Graphing Quadratic Functions, Standards, MA 912, AR 1.1, 3.4, 3.8, and F 2.3. Graphing quadratic functions, you need to remember that the standard form is in the format of y equals ax squared plus bx plus c, where a is not equal to 0. The quadratic function has a graph that's known as a parabola, so we would see it looking like a parabola. Then the need to know the parts of your parabola, your equation. So in our equation, the ax squared part means that's the quadratic term. When we see plane bx, that's the linear portion, our line part, and c is known as our constant piece. When we look at the quadratic function, we have an axis of symmetry, which is the line that splits your parabola in half, and it's known by the equation x equals negative b over 2a, which is also used to find the vertex of our parabola for the x coordinate. The vertex of the parabola either has a minimum or maximum, so our peaks and dips. It will have a minimum when it opens up, and it will have a maximum when it opens down. Example 1, graph a quadratic function by using a table. So they want us to graph the equation f of x equals x squared plus 2x minus 3. So first we need to identify some key features. So first we're going to identify what the a, the b, and the c. Remember, the original parent graph is y equals ax squared plus bx plus c. So our a value is the value that's in front of the x squared, which is a 1. Our b value is a 2, and our c value is a negative 3. So c is also known as your y-intercept. So in this instance, our y-intercept is at negative 3. So 0, negative 3 would be our y-intercept. To find the axis symmetry where our equation is going to split in half, we're going to use the standard form for the axis symmetry equation, which says x equals negative b over 2a. So we're using negative b is a 2, so I'm writing 2 on top. 2 times the a value, which is 1, so negative 2 divided by 2 makes it negative 1. So our axis symmetry is x equal to negative 1, which is also the x coordinate of the vertex is also negative 1. Since a is greater than 0, the vertex is a minimum. Since the a value is greater, remember, if a is bigger than 0, you have a minimum. If a is less than 0, you have a max. So when we go to graph the equation, we are taking our original equation, x squared plus 2x minus 3, and we're going to use some test values for x. And we started with negative 3, negative 2, negative 1, 0, 1, so you want to have negative and positive values. So when we stick in negative 3 in for x, we get negative 3 squared, that's a 9, plus 2 times negative 3, which is negative 6, minus 3. Well, 9 minus 6 is 3, and 3 minus 3 makes it a 0 value. When we stick negative 2 in, we get negative 2 squared, that's a 4, plus 2 times negative 2, that's a negative 4. So 4 minus 4 is 0, minus 3 makes it negative 3. When we stick negative 1 in, negative 1 squared is a positive 1. 2 times negative 1 is negative 2. So 1 minus 2 is negative 1. Negative 1 minus 3 makes it negative 4. When we stick 0 in, well, 0 squared is still 0, plus 2 times 0 is still 0, and then a negative 3. And when we stick positive 1 in, 1 squared is 1, 2 times 1 is 2, so 1 plus 2 is 3, 3 minus 3 makes it a 0 value. And then we plot our points. So negative 3, 0 hits our x-axis, negative 2, negative 3, negative 1, negative 4, that is our vertex. 0, negative 3, here is our y-intercept. And then we have negative 1, 0 again here. This is also an x-intercept. And this is our other x-intercept. So when we go to analyze our graph, the parabola extends to positive and negative infinity. So the domain, so notice that what it means by that is that my graph is going, the x's are going to the left, So we're analyzing the graph. The parabola extends to positive and negative infinity. What that means is we notice that our x's are going to the right and to the left. So our domain is going to be all real numbers. The range, though, the range has the lowest values at the peak, which is -4. So where y is greater than or equal to -4. Now, in behaviors, what is our graph doing in terms of going left and right? So as x goes to positive infinity, as x goes to negative infinity, correction, as x's are going to the left, the y's are going up. So I'm going to positive infinity. As x's go to the right, the y's are going up to positive infinity as well again. The function is decreasing. Decreasing, what is the graph? What's it doing? So when we look at our graph, it's decreasing as x is less than -1. All the values from x less than 1. And then it's increasing as x is greater than -1. It's going to be positive, which means above. This is what it's talking about. Above the x-axis. Between when x is less than -3 and x is greater than 1. It is negative in between the two values. So from -3 less than x less than 1, that is when I am negative. I'm below the y-axis. The vertex and factored forms. So our vertex form allows you to easily find the vertex of the parabola. Normally the formula is y equals a parentheses x minus h closed squared plus k, and our vertex is identified as hk, which we learned in a previous lesson. The factored form, on the other hand, it allows you to easily identify the zeros of functions, so where it hits the x-axis. And normally the general formula that we use for that is y equals a parentheses a times x minus p parentheses x minus q. And then our p and q are our actual x-intercepts. In example 2, it says graph f of x equal to 1/3 parentheses x plus 1 squared plus 2. They want us to state some key features of the graph. So first thing, the 1/3 is in the place of where the a value would be, our h. To find h, it's the same thing as saying x. So we're going to say x plus 1 equal to 0, so x equal to -1. So the h value is -1, and our k is the same thing as our y-intercept. So in this one is going to be a 2, so -1, 2. So when we look at our graph, it says step 2 says they gave us -4, -1, and 2, and they want us to do the numbers plugged in -4, -1, and 2 into the problems, and we get ordered pairs of -4, 5, -1, 2, and 2, 5. So we're going to plot those points. So -4, 5. -1, 2, and then 2, 5. And our parabola is opening up in this instance. And I also noticed that if I were to draw an axis of symmetry, because remember our axis of symmetry is x is equal to -b over 2a, which is the same thing as saying whatever our hk value, our h value, is where our axis of symmetry. So our axis of symmetry is located at -1 as well. When we look at our problem, the domain, remember our x values, so they're all real numbers, but our y values in this problem, our y values do not drop below +2. So our range is going to be from y, where y is greater than or equal to +2. Our x-intercepts, there are no x-intercepts because it does not cross the x-axis. It does not cross the x-axis, so there will be no x-intercepts. The y-intercept means it hits the y-axis at 7/3. Now, when we look at our graph, it's asking about it's increasing and decreasing. Well, we are decreasing from -infinity to basically -1. So it means when x is less than -1 is when we are decreasing. We are increasing when x is greater than -1. Now, it's asking about positive and negative pieces. We don't have any negative pieces. We are all positive in this instance because we're above the x-axis. Now, end behavior. End behavior is asking us what is our y's doing as x's go to negative and positive infinity. As x's go to the left to negative infinity, we are opening up, so we're going to positive infinity. As x's go to the right, positive infinity, the y's are also opening up to positive infinity. our line of symmetry, as I stated earlier, is the line where it's going to split. So the line of symmetry is going to be around the line x equal to -1. Okay, in example 3, they want us to use the quadratic function in factored form. So they gave us the problem f of x equals -2, parentheses x plus 2 times x minus 1, and they want to say key features. So when you're looking at our thing, our -2 is in the same position as where normal a be. Our x plus our p values, so remember, you're going to take each piece set them equal to 0. So I did x plus 2 equal to 0, so x equals -2. So I have a p value at -2, and you do the same thing with your q. So x minus 1, set that equal to 0, so x equals +1. So our q value is at 1. So we have x-intercepts at -2 and +1. That's when it hits the x-axis. Then in step 2, they picked some points, -3, -1/2, 0, and 2 to test values into our problem, and came up with solution points of -3, -8, -1/2, 4.5, 0, 4, and 2, 8. So we're going to plot those points. So -3, -8, notice that it's increments of 2. So we're down here in the quadrant 3. -1/2, 4.5, came a little bit past the 4 and a little bit to the left of the 0. Then we have a point at 0, 4, means it's coming back down, and then 2, 8. So our graph went up and then came back down. Sorry, it's a rough sketch. Okay. So now when we look at our problem, it says the domain. So the domain, remember, domains are your x's. So it's going to the left and right. It keeps opening, so it's going to be all real numbers. The range are our y values. So notice that y is below the 4.5, pointing down. So our x-intercepts when it hits the x-axis. When it hits the x-axis, remember we found them in our ordered pairs earlier. It was -2, -2, and 1. So we have intercepts at -2 and +1, and our y-intercept is at 4. It's increasing, decreasing, it's increasing. We are going in a positive direction when x is less than -1/2, and we are decreasing when x is greater than 1/2. What that means is we're going in a positive direction here and a decreasing direction here. Then it asks about the positive and negative regions. So we're going to be positive in between our values from -2 to the +1. This is when we're in the positive side of it. So between x is x if and only if x is -2, less than x, less than 1. We are negative when x is to the left of -2 or x is to the right of +1. When we're talking about end behavior, what's happening to our y's? As x goes to -infinity, our y's are going to -infinity as well. As x goes to +infinity, our y's are also going to -infinity. The vertex we identified from our problem was -1/2, 4.5, and our line of symmetry. Remember, your line of symmetry is based off the x value of your vertex, so when x is equal to -0.5. So writing quadratic functions, if we have a vertex, if we know the vertex and a point on the parabola, we can write an equation using the vertex form of the quadratic function. So we're going to use the vertex form of the quadratic equation to create that equation. So if we look at example 4, it says write a quadratic function from a graph. So they gave us a graph, and it says write an equation that models the function graph. So in here, we know that the vertex is at -2, 5 because they gave it to us in our graph. And we can notice that, so we're going to plug in for our equation, y equals a, parentheses x minus h squared, plus k. Remember, it's going to be the opposite sign, so I'm going to write -2 in parentheses, and then our 5, because you need to write in h, -2 and 5. So when we plug in, negative makes it +2. So we now have our equation that says y is equal to a, parentheses x plus 2 squared, plus 5. Then we pick another point. So in this instance, they use the point -1, 2, because when we look at our graph, you pick any point. They used -1, 2. We could have used the point -4, 2. We could have also used down here in the bottom region -1, -1/2, -2 for it as well. So they use -1, 2, and they're going to plug in for x and y. So they plugged in for x and y in our problem. So they wrote 2 equals a, parentheses -1 plus 2, close squared, plus 5. They did the math inside. -1 plus 2 squared is a 1, and 1 squared is 1, and 1 times a is a, plus a 5. And then they subtracted the 5 over is what they did to get an a value of -3. And so they know the a value, so we know our a is -3. We know our h value is -2, our hk value is -2, 5. And they took the general formula, y equals a times h minus k squared plus k, and all they did was replace our pieces. So when they did our pieces, they plugged in for a, h, and k, so that's where they got y equals -3 times h plus 2 squared plus 5. Now, when they got to the standard form, to get the y equal -3x squared minus 12x plus 12x minus 7, what they did was they expanded our equation. So they had the y equals -3. They expanded x plus 2 squared, and that became x squared plus 4x plus 4 plus 5 on the outside. They distributed and got y equals -3x squared plus minus 12x actually. Minus 12 plus 5, and then they just combined like terms, and that's where they ended up with the y equals -3x squared minus 12x minus 7, which is what the standard form is. In example 5, they want us to use the quadratic formula from a table. It says write an equation that models the functions given in the table. It says we know that the function is quadratic. So it says we know the function is quadratic. So, and it has 2 zeros that are given. So here's a 0, here's a 0. So they're going to use the y equals a parentheses x minus p times x minus q, this using the factored form. And what they did is they replaced those values in. So they replaced p and q. So they ended up with a parentheses x plus 3, x plus 1. So then you can pick another point. So in this instance, they used the y-intercept and plugged in for x and y. So we're going to put a 3 here. A, we don't know. X is 0. X is also 0. Well, in here we get 3 times a times 1, which is 3a. And then we divide both sides by 3 and we got the a value of 1. So when we went to write back our equation, the a value, normally we don't put the 1 there, but it's there. Now, if they wanted standard form, so remember we are x plus 3, x plus 1. We are distributing out. We're FOILing out, multiplying, box method, whatever you want to do. So you become x squared plus 4x plus 3. That is our standard form. Y equals x squared plus 4x plus 3.